Hello and welcome to Team Teats' presentation for Smart Grid Metering Technology. With a growing population and ever-increasing need for energy and a dwindling supply of fossil fuels, the need for renewable energy is of the utmost importance to many countries in the world today. With solar, wind, and even tidal prime movers taking the spotlight, it's becoming difficult to monitor and integrate these new power sources into our existing grid. This is where the smart grid comes in, a simple solution to a complex problem. By exchanging information along the power lines, the smart grid can accurately monitor power consumption, provide active diagnostics for power deficiencies, and respond to the need of consumers quickly and reliably. Smart Grid also allows for real-time tracking of faults along the lines and can reclose sections of the grid automatically in the case of a transient fault, or dispatch crew to the site of a permanent fault for repairs. The monitoring applications of the Smart Grid provide simple yet accurate metering solutions for a wide range of both producers and consumers. With information passing quickly from generating stations to customers and back again, the Smart Grid provides an inexpensive medium for billing along with monitoring supply and demand in different regions of the province.
Okay, so what Tim just described there was advanced metering infrastructure. Again, with a complex grid involving two-way energy flow, it's important that meters can perform a number of functions. And meters today do just that. They're able to provide two-way communication from the utility to the equipment outside your door as the end user. Some meters are also able to provide functions such as remote connect and disconnect and user interface and monitoring, which allows end users to view the energy that they have consumed and to manage the energy that they are putting back into the grid.
This is a basic smart meter in the Power Stream service territory. The Ontario Energy Board approved a smart metering charge of 78.8 cents per month to be collected from distribution utilities. This charge covers the cost to develop and implement the meter data management repository. However, this charge is not transparent on our bills. It is hidden or integrated into our bills. These are two different types of smart meters available from General Electric. The top meter costs $60 and is a basic meter with functions that include time of use, demand metering, and service switching capabilities. The bottom meter is the most advanced meter available from General Electric. It costs $160 and is intended for residential or commercial use where renewable energy is being collected, used, or sold back to the grid.
Smart Meter Manufacturers Association of America is a consensus-based advocacy group of smart metering manufacturers. They represent roughly 98% of installed electric meters currently deployed. The purpose of this association is to educate legislators, regulators, media, and stakeholders on the benefits of smart meters, as well as advocating federal and state policies. Although members do compete for business in the marketplace, they equally support energy and cost recovery policies to encourage utilities to deploy smart meters technologies. Members are world leaders in measuring, managing, analyzing, and improving the flow of electricity, water, and natural gas. By overcoming operational, regulatory, and customer-driven challenges, they have expanded to over 130 countries with over 200 million metering modules deployed from utilities to cities, industrial complexes, and campuses.
Alright, one of the companies in the association Sam just talked about is Elster. It has a really impressive energy access system that incorporates many of the features I talked about earlier. For example, a utility company in Phoenix has implemented the energy access system, and to date they have used the system to complete over 1 million service calls remotely. Just to give a bit of perspective, projects like the one I just mentioned are going on all over the world. This map is a detailed representation of these projects. and we can see that there are advanced metering infrastructure projects and smart grid projects occurring all over the globe.
As of 2013, there are approximately 313 million smart meters around the world. It is expected that the penetration of these meters will increase to 1.1 billion units globally by the year 2022. Utilities in Spain, France, and the United Kingdom currently have projects underway which will account for approximately 93 million units by the end of 2020. India has pilot projects planned to implement smart meters at the later end of this decade, which will account for more than 150 million devices. Japan is expected to account for approximately 80 million units. Europe is expecting to employ smart meters to 80% of the population by 2020.
With all these new projects, security breaches in the smart grid can result in a variety of serious consequences, from blackouts and physical damage of infrastructure to the leakage of customer information. Although most of the architectures, frameworks, and roadmaps for smart grids have already been defined by the governments and industries, there are still many important security and privacy issues in smart grid communications. But these issues are now considered by governments and the industry to be one of the highest priorities for smart grid design, and they must be resolved before smart grids can be operational and ready for the market. A number of organizations have been actively working on the development of smart grid security requirements. A few are the Electric Power Research Institute, the International Electrotechnical Commission, and the National Institute of Standards and Technology, and others. All organizations constantly specify 3 smart grid security objectives: availability, integrity, and confidentiality. Availability refers to ensuring timely and reliable access to information, which is the primary security goal of a smart grid metering and control system. Attacks targeting availability can be considered as denial of service attacks, which intend to delay, block, or even corrupt the communication in the system. Integrity refers to preventing or detecting the modification or destruction of information by unauthorized persons or systems. Attacks targeting the integrity of a smart grid attempt to manipulate critical data such as meter readings, billing information, or control commands. Confidentiality refers to protecting personal and property information from unauthorized access. Attacks targeting confidentiality aim at obtaining desirable information, for example, power usage, customers' account information, by eavesdropping on communication channels in a smart grid metering control system. The complicated system architecture has made securing the smart grid particularly challenging. Security in the smart grid metering and control system is an important and rapidly evolving area that has been attracted attention from governments, industry, and academies. Smart grid metering control systems hold enormous promise for improving efficiency, convenience, and sustainability.
This ends our presentation on smart grid metering. I'm Tim Robbins.
I'm Ethan Levedell-Baker.
Andy Lovass.
I'm Tom Hewitt.
And Sam Grado.
And thank you for watching.